Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about proving triangle congruence. Alright. So before we prove congruent triangles, first we need to know how to write corresponding statements. So in writing corresponding statement, match up the vertices correctly to make the correspondence. So for this example, we have triangle BAG and triangle VET. We know that they are similar to each other. So since they are similar to each other, we can say that we have corresponding angles. We can say that angle P corresponds to angle V, and angle A corresponds to angle E, and angle G corresponds to angle T. Alright. Also, since we have corresponding angles, we can also have corresponding sides. Side BA corresponds to side VE. Side AG corresponds to side ET. And side BG corresponds to side VT. Now, since they correspond to each part of our triangle, we can say that triangle BAG corresponds to triangle VET. Alright. Okay, so let's talk about triangle congruence. So we can say that two triangles are congruent if and only if all their corresponding parts are congruent. Let's look at the congruent symbol. So congruent symbol is this one. It is an equal symbol with a squiggly line on top. The squiggly line represents the similarity of the two figure. It has the same shape. Now the equal symbol represents equality. The measurement of the corresponding parts are the same, so they have the same size. Here are some postulates and theorems that can help us in proving triangle congruence. So our first postulate is the side postulate, wherein if three sides of one triangle are congruent to the corresponding sides of another triangle, then the two triangles are congruent. So here are examples of triangles having the same corresponding sides. So side BR is congruent to side AN, side BO is congruent to side MA, and side RO is congruent to side MN. So this is enough to prove that these two triangles are congruent. We can say that triangle BRO is congruent to triangle NAM. Alright. Okay, next postulate is the side angle side postulate. Now if two sides and the included angle of a triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. Let's have an example. Side CH is congruent to side LI. The angle CHU is congruent to angle LIN. And side HU is congruent to side IN. Knowing that we have these three parts of a triangle being congruent to each other, we can conclude that triangle CHU is congruent to triangle LIN. Now, take note that this side angle side postulate will only work if we have two sides and one included angle. Alright, let's talk about the next postulate, which is the angle side angle postulate. If two angles and included side of a triangle are congruent to the corresponding part of another triangle, then the two triangles are congruent. So let's have an example. So for this example, we can say that angle H is congruent to angle D, and side HP is congruent to side DB. Also, angle P is congruent to angle B. This is enough to conclude that triangle HAP is congruent to triangle BID. Okay, let's talk about the last theorem that we're going to discuss in proving triangle congruence. So we have the side angle angle theorem. So if two angles and a side opposite one of the angles in one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So let's have an example. So for example, we have this. So we can say that side RP is congruent to side EO. That's our side. Now, angle A, the opposite angle of side RP, is congruent to angle X, which is the opposite angle of side EO. Then, one of the angles are also congruent, angle R and angle E. So this is also enough to conclude that triangle RAP is congruent to triangle EXO. Alright. Now that you already know how to prove triangle congruence, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.